very good morning to all of you. I'll sit down because otherwise some of you won't be able to see the pictures. Now you can put your smartphones away because I hope you're all fully awake. You'll get a slow movie within 20 minutes, 45 slides, but you can get the PDF afterwards. And so let's start. I really focused on research needs. But let's start with where did it all start? 1976. I wrote a report for the European Commission on the potential for substituting manpower for energy. And the result was the circular economy, the definition of the circular economy. And with the two loops, I called it an economy in loops, because a circular is a perfect shape, whereas a loop can be any shape. And you have a one loop, which is reuse, remarketing, reman, tech upgrading, where you preserve embodied resources, and you are cheaper than new production. And you have another loop, which is material recycling, where you have the problem that the virgin products have a higher purity, are cheaper, so you are basically not in business. But you can still do recycling. So, second thing is, what is the link between sustainability and the circular economy? It's two sides of the same coin. One is qualitative, the other one is quantitative. The physical world versus the objective of happiness. And where is the borderline between linear industrial economy and the circular economy? It's the point of sale. So anything before the point of sale is production. Anything after the point of sale is circular society or circular economy or circular industrial economy. It's about managing stocks of objects and managing stocks of materials. What is the impact on society? Anders Weikmann and Christian Skanberg produced 7 reports on European countries. If we have a shift to a circular economy, what does that mean? And in all these 6 or 7 countries, the result was the same. Greenhouse gas emissions would go down by 2/3, jobs would go up, and the trade balance would go up. They were using input-output model. So the question is, this is single research studies done by private people. Why is there no general academic interest in this? We are all talking about reducing greenhouse gas emission and creating jobs, but it doesn't seem to interest anybody that there is a way to do it. So let me look at the circular economy in a backcasting view. In other words, you go to the future and then look back. And if you do that, you can see there is the era of R, which is reuse, remanufacturing, repair. You have the era of D, which is recovering molecules or atoms as pure as new, otherwise you are not competitive. And you have a liability loop that is completely missing today, and you have the innovative new materials and components to maintain the stock. So let's look at these things one after the other. What are the challenges? There is an R&D challenge in the area of R and area of D. There is a policy challenge in the liability loop, and there is an educational challenge because the knowledge is all there. But spreading the knowledge to classrooms and boardrooms, academic institutions, is the educational challenge that is at the moment very selective. Let's first look at the area of R, circular user economy. The objective is maintaining value, quality and quantity of stocks. the buyer owners of the object are in control, that is you and me. You are in control of your cars, your smartphones, all that, and you decide when to throw it away or not. The research needs, I'll let you read the things. There is a huge collection of challenges and research needs, but the basis of the area of R is the use value of objects and trust. Yeah, I should have asked you before, do you ever buy and sell second-hand goods? And how often, every time you buy or sell a banknote or a coin, you are in the circular economy. And why do you trust, completely stupid, why do you accept a 20-year-old 20-euro note for 20 euros, whereas 20-year-old car you wouldn't give a penny? Because somebody, the National or the European Central Bank, is guaranteeing the value. Never mind in what state the banknote is. So it's not about technology, it's about value and trust. And then if you look at how is the linear industrial economy at the bottom here different from the circular economy, but I use the measure of man-hour per kilogram and euros per kilogram, and if you do that you realize it's two different worlds. For example, the remanufacturing a car engine has 270 times higher man-hour per kilogram ratio than producing a car engine. So we are not talking about factor 10 or something, we are talking about factor 270. But again, doesn't seem to interest any academic researchers. I mean, the important thing is to better produce car engines in economics. Another thing, the return on investment of remanufacturing plants is 5 times the one of the plant manufacturing the same engine. So if you are interested in money, profits, whatever you call it, go to remanufacturing. So far there are very few, Volkswagen, Renault, Caterpillar, that have really accepted this principle. I don't know a single university that seriously looked into this. Then public procurement, if you want to be cheap and green, I let you read the details. Redesigning the intercity express trains of the German Deutsche Bundesbahn, Deutsche Bahn. In the meantime, the IC1, the oldest generation, has already been redesigned, remanufactured a second time. Just look at the cost savings, 3 million versus 25 million. I mean, why is not everybody going for the cost-beneficial solution? And you get the environmental benefits free of charge. So, and where is the academic? This is a study I did for the Deutsche Bahn. Where is the academic research looking into this? Because the Swedish railways, the Dutch, I mean, there are plenty of things you could do research studies on if you are interested. Then design innovation is needed. For example, if we want reusable packaging, it has to be, one solution would be stainless steel cans that can be stapled. This comes from one of my students in 1992, the design, what is it called, Hochschule für Gestaltung in Ulm, but it was never commercialized because industry is not really interested. Then long life means you. Again, it's not industry that will produce the long life goods, it's you. You have on the right, you have my HP 12C calculator from 1972. You have my Toyota from 1969. You have the teddy bear that comes from the Victoria and Albert Museum. But basically, social innovation in behavioral research, if goods become teddy bears, they live forever, or at least as long as you live. But it's you that decides, not industry. And so one of the important things, if you do that step, then you become a user. You buy performance or results or goods as a service, and the consumer is dead. That means sharing goods, and sharing means caring, otherwise it doesn't work. These are just a few examples of objects as a service. It's like the banknote. You probably never looked at it that way, but these are objects as a service. Even Carnegie Hall, you never buy Carnegie Hall to listen to concept. The problem with sharing is we need social innovation. It's, if you want to build an efficient laundromat, the problem is not the washing machine. The problem is to make it attractive for people to go there. Because otherwise people hate laundromats. Autolib rent-a-car in Paris was a big success. It was a perfect rental system. It failed due to abuse and vandalism. So if you have users using your goods and they destroy them, there is no way that you can make profit. Same story for Mobike, Chinese or Singapore company. It was the first cheap, low maintenance, use where it is bicycle system in many cities of the world. It's arrived in Oxford because you have students behaving. It failed in many other countries, and yet, for example, that it's the first bicycle where you never have a flat tire, because the tires are, you don't have to inflate them, and yet they are soft. So there's a lot of innovation in zero maintenance goods. Okay, that was the area of R. Now let's look at the area of D, from end of life to as poor as new resources. Maintaining the value and purity of elements. The owner-manager in control is what we call the waste managers or resource managers. What is happening today? You have, this is again a study from a Swedish consultancy comparing on the right the today's, that what Walter mentioned, recycling system, recycling rates, and on the left in percentage the value retained in one full cycle. So if you look at steel, it's fantastic in Sweden. Recycling rate 75 to 95%. The value retained is 32% in one cycle, which means in the second cycle it's 32 of 32, which is 20%. And after the third or fourth cycle, your value has disappeared. So the factor time in and the recycling, let's forget recycling. As a waste management strategy, let's look at it as a value maintaining strategy, and then we are doing everything wrong. This is the conclusion that the Swedish Recycle Association got from this study. If you look at plastics, 53% are recycled, value maintained is 8%. It's ridiculous if you look at the costs of collection and all this. Then The area of D means delaminating, depolymerization, deconstruction. Look at carbon fiber laminates, which are used in cars, all the airplanes today, windmill blades. There isn't a single technology of what to do with this stuff at the end of its life. It was the same with the fiberglass laminates. And then you look at the operation and maintenance challenge. You see the two engineers trying to repair this thing up there. Is this really a renewable energy? Is this really a sustainable strategy? If we produce mass waste in 20 years, and we know we don't have a strategy to, then deconstructing buildings, the challenge is not only to recover components and materials, it's also to recover the energy. Because you hoisted up all the stuff, now it comes down, so you can obviously recover the energy. So far there is one single study, and low noise, low dust, it's very sustainable, but very labor intensive. Then the extended producer liability, which basically means if you don't know what to do with something, give it back to the producer because he must know how he built it. So if we define waste as objects with no positive value and no ultimate liable owner, can basically either give these objects value or we can nominate an owner. So it's a policy innovation. And the reaction of these, if this is introduced, the reaction of industry will be to avoid this liability, which means moving into a performance economy. But just performance economy means the manufacturer, producer retains ownership and has to internalize all costs and liabilities. It also means the buyer has to buy the result, the performance, instead of buying the goods. And then you have, if you take lighthouses as a typical system solution, who is going to finance this kind of innovation? It helps society, it's useful for everybody, prevents waste, accidents, but why should anybody put money into this? If you look at power by the hour jet engines by GE or Rolls-Royce, if you want to, instead of selling jet engines, you want to do operational leasing, you need financial innovation because you get your money much later than if you sell them. And you need technology innovation because preventive maintenance is something that you have to integrate into the product before you produce them. If you do the remanufacturing in where you produce the things, it is much more efficient. So therefore you have to have components that you can simply change, such as life rafts on the Queen Mary. It's fantastic because the ship no longer has anybody working on it. They simply, when they come into port every 2 years, all these life rafts are exchanged and for new ones or for remanufactured ones. The same with paper lux. All these things exist. It's spreading the knowledge which doesn't work. When have you last read a newspaper article about these or similar examples? Journalists are fascinated by new products, but not by then sufficiency solutions. The circular economy is regional because the needs and the opportunities are very different in different places. If you are in a rural area, you can have wastewater treatment plants that don't need any concrete, no pumps. They don't produce any waste, but they need space and knowledge. If you want to make for to build a bridge, for example, the Pont de Viaduc de Millau, to build a bridge without any cost to the state. You have to make it clear that whoever builds this thing under a 70-80-year contract will be in charge of all the maintenance costs. Not only construction, design, finance, but also maintenance. The only thing he gets is a toll from every car, every vehicle passing. So how do you build a bridge with zero maintenance and where you only know the financial result after 78 years? The bridge looks the same as any bridge, but the way it is built is very different. NASA 20 years ago decided only to buy commercial launch services, no more hardware, and the result is that 10 years ago a dozen companies in the States said, okay, we'll go for space, including SpaceX for the moon. All these companies in the meantime have produced the strongest rockets that ever existed, and rockets that are reusable. Rockets that land on propulsion, they land the same way and the same place that they took off, so they can be reused. And these are private startup companies. The big ones, Boeing, and that used to build the Atlas rockets, they have no chance because their mindset is completely different, and they cannot compete cost-wise with SpaceX. So then let's come to the final point, injecting in innovative ideas into managing these stocks and into replacement products. First thing is design for the future. So if you want to have a dust energy building using hydrogen fuel cells and photovoltaic panels that don't exist yet, you have to make the building as if these things existed, so that when they come online 20 years later, you can integrate them into the building without any special cost. If you look at smartphones, in this case, the big thing, CO2 emissions here, in the smartphones are extraction and manufacture. And that's where everybody focuses. But you cannot use a smartphone without all the network. If you study all the network, you will realize that the big greenhouse gas emissions are not in the phone, they are in the network. So if you want to optimize the system, you first have to understand the importance of all the different systems. Very often you need a mobile concept. Even if you are Tata Steel and you want to help the farmers, then you have to produce mobile units that go to the farmer. It's not the other way around. Then systems optimization research. I've given you just 3 examples: hydrogen, fuel cell, electric motors powering trains. Now it already exists in Germany, in the south and the north of Germany. You'll never find anybody, journalists, talking about it. Ships, Norway 2020 will have the fuel, the first Hurtigruten express ferries powered by hydrogen and fuel cells. Trucks, cars, buildings, but it's something that exists in Japan. Norway is going full hydrogen, despite the fact that they have gas and oil. But it doesn't seem to interest really most of the other countries. Then cold science, you can do your washing with cold water, so you save 80 or 90% of energy. The latest thing that was in Nature a couple of weeks ago, to combine hardening principles of metallurgy with architected materials, you may be able to get away with alloys. And if you can reduce the number of alloys, you will have much higher recycling rate. But then also understanding, because we have a lot of knowledge in science that we have forgotten. Just two examples: plowing at night. The Amish have always plowed at night, because then you don't have to do the weeding. You don't need any or very little weed killer, because nature has a system so that if you plow at night, the weeds don't realize it's spring. Or when the mukba, these brass containers were replaced in India with plastic or metal aluminum containers, suddenly we had epidemic illnesses spreading simply because the brass vessels give off copper in minute quantities that kill the bacteria in the water but don't harm the people. So understanding what you are doing is absolutely key. If you want to, the diagrams I showed you will be in this new book, The Circular Economy, a user's guide, or in the performance economy. I can give you, if you send me an email, I can give you a copy of an e-book of the performance economy, 300 examples, because it's 8 years or 9 years old, so I can give it to you for free. There is a Chinese version in simplified Mandarin, but unfortunately I don't have that as an e-book. What's policy innovation? If you accept that circular economy is a substitute of manpower for energy, it's obvious that if you don't tax labor but tax waste and resource consumption, that you push industry into a circular economy. But policy can also be an obstacle. We did a study 15 years ago in Austria. If you look, the legislation today is promoting industrial linear industry. If you go the other way, you run into a number of obstacles. So policy adaptations, it's also in the vocabulary. You have to, in order for people to realize that the circular economy is not what they always have. So forget the consumer, except for food. You have to talk about users. So sustainable consumption is an oxymoron, a contradiction in itself. It has to be sustainable use. Now try to change any terminology in the UN. It normally takes about 1,000 years. And wasted, let's not talk about waste, let's talk about wasted resources, because then everybody realizes what it is. And let's forget recycling rates, stipulate annual resource loss in financial terms, that is a lot. That's just a summary. Thank you very much for listening.